Hi, welcome to Physics on Table channel. Today I will teach you how to find eigenvalues. Okay, so let's start. For that, I would like to teach you how to solve a cubic equation first and how to find determinant in a shortcut way. Because in competitive exams, you have to follow some tricks for solving the problems. If you follow the general trend, that will take much time, and if you can save time, you can attend to two more questions and can get 2 to 4 marks more, right? And that can uh, be very essential for your rank. 2 to 4 marks can make a big difference of 300 ranks. Can 1 mark can make a difference of 100 rank. Don't think of that. I'm experienced, I know this. So let's start. Okay, so shortcut to find determinant of a given matrix. Okay, so let's go to the next page. Suppose we have a given matrix A and it is given as 4 3 1 2 1 minus 2 1 2 1. Okay, this is our given matrix. If you do this in general method, you have to hide this line and this line, take this as a product and so on. You know this how to solve. But here I am going to discuss a shortcut. So let's do that. Okay. So here we have 4 3 1. Okay. 4 3 1. We have 2 1 minus 2. 2 1 minus 2. We have 1 2 1. 1 2 1. What you people need to do is that just write this 2 column again. Okay, repeat this 2 column again. 2 1, sorry, 4 2 1 3 1 2. Listen very carefully, please. Let me okay 1 minute. So just write the matrix in the given form and just repeat the 2 columns as I have done. Okay, so have you seen reflection, the diagrams given in your optics book? Reflection in optics chapter. What actually happens? Light ray falls like this and gets reflected in this manner, right? You have to follow the same trend over here. What you need to do, take this line diagonally, that is same as a light wave. Again take this line diagonally, again take this line. Okay, now this is the incident thing. Okay, I'm just finding an analogy between the two, and again this one, this is the reflected one, this one, this one, and this one, right? So what you need to do is you need to multiply these things. Let me change the color. Yeah, you have to multiply this line. All the entities in this diagonal you have to multiply. Same, you have to multiply this line. Again, you have to multiply this line. Okay, what you need to do is you have to multiply. I'm telling you that is 4 into 1 into 1, it's 4, plus you have to add them again, plus 3 into minus 2 into 1, it is minus 6, right? Again, 2 into 2 into 1 is 4, so 8 minus 6 is 2, right? Okay. See, what you need to do is you need to multiply this line. Again, 1 into 1 into 1 is 1, plus this line 4 into minus 2 into minus 2, how much? Minus 16, right? Yeah. 3 into 2 into 1 is 6, so it's minus 9, right? 7, yeah, minus 9. So from the incident one we get 2, and for the reflected one we get minus 9. So this is known as S1, and this is known as S2. S2. Okay. So what the short trick says is that we need to do, for finding the determinant, we need to do S1 minus S2. S1 from the previous page we are getting 2, and S2 is minus 9, so our determinant is 11. Okay, this is the short trick you can apply in competitive exams, and it will take merely 2 minutes or less than that, sorry, not 2 minutes, less than that, 1 minute I think maximum, for finding determinant in the shortcut. You can find you can also apply the traditional technique, whatever you like, and kindly comment you are getting 11 or not from the determinant, because I haven't checked the traditional technique for this problem. Okay, kindly comment it down. So okay, this is how we can find the determinant in a shortcut method. So we are going to follow this method for solving for finding the determinant. Okay, nice. Okay, so let's go to the next page. Let me change the background. Which one you want? This is the problem in online teaching, no? You people can say which one you want in offline thing. Okay, whatever, it doesn't matter. Let me get this one. Yeah. Okay, so now I am going to teach you how can you solve a cubic equation. This is not a shortcut, this is the conventional method. So how to solve cubic equation. Suppose we have a cubic equation and we need to solve it. Suppose the equation is minus 12 lambda square plus 36 lambda minus 32 is equal to 0. What we people need to do is we need to find the value of lambda. I hope you remember that in a squared quadratic equation we are getting two solutions. If this is a quadratic one, suppose lambda square is the leading coefficient. leading power actually. So we are getting two solutions. For a cubic we get three values of lambda. Okay, three lambdas we get. It might be degenerate or non-degenerate. Degenerate means uh, degenerate means same value, and non-degenerated means unequal value. Means you can get 2 to 1, or you can get 3 to 1, like this. This is an example. I don't know what is the solution of this problem. So let's do it. How to do? So we have lambda cube minus 12 lambda squared plus 36 lambda minus 32 is equal to 0. Excuse me. So what we need to do is that we need to find the factors of the last digit given in this equation. 32 is there, यहाँ पर 32 दिया हुआ है, तो हम लोगों को इसका फैक्टर निकालना पड़ेगा. ओके, we need to find the factor of this number. So what can be its factors? It can be 1, it can be 2, it can be 4, it can be 8. Okay, it can be 16, it can be 32, but we are not writing the factors. I think you know. Okay, if you forgot, I'm just try to recapitulate it. Factors are nothing but the terms that we 32 can be divided. Okay, like 32 can be divided by 1, 32 can be divided by 2, 32 can be divided into 4, 32 can be divided by 8, 32 can be divided by 16, 32 can be divided by 32. But our main objective is that it shouldn't cross this number. It shouldn't cross 12. Okay, so we can't write 16 and 32 in this equation. That you people need to remember. This is kind of shortcut thing, and if you actually there is a shortcut, we don't need to proceed again. See, one thing, this is a little bit risky, but you can follow it in some problems, but don't do it, it's my request. Faulty my talk. So see, what we need to do is that we need three solutions. So we need to add this any of three or two numbers in such a way. In total we will get three solutions. Okay, in total we people are going to get three solutions. So it can be 8 plus 4, but see 8 plus such that the sum is going to be 12. We need to add any three numbers. It might be repeated, not repeated, but we need to add in such a way the summation becomes 12, not minus 12, 12. Okay, and here if it is plus, the same formula is applicable, but don't follow this rule, it's just a shortcut. So see, 4 plus 2 plus, no, not applicable. 8 plus 4, two numbers is 12, two numbers are giving the result. 4 plus 2 plus 8, no, it's exceeding. So what is left? 8 plus 2 plus 2, it's 12, right? 8 plus 2 plus 2 is 12. So yeah, actually these are the three solutions. This is a very shortcut method to find that this is not the traditional method. So it's better to do with traditional method this kind of problems, because in some of the problems the shortcut method might not be applicable. So what you need to do is that, let me rub this. So the factors we are getting, this equals to 0, are 2 to 8. Kindly bring your calculator, it is required. No, not 2 2, it's 1 2 4 8. This number shouldn't exceed for the factors. So what we need to do is put 1 in this equation and see it's giving 0 or not. If you put 1, it's 1 minus 12 plus 36 minus 32. It's not equals to 0. You can easily conclude this. This is not giving us 0. I don't know why it's not rubbing. Okay. Minus 32. No, it's not giving 0. Now put 2. 2 to the power 3 is 8. 2 square is 4. It's 48. If you put 2, it's 72 minus 32. So check. Yeah, this will give you 40 and this will give you minus 40. So it becomes 0. So yeah, 2 is a solution, it's proved. Let's go to the next page. Our equation is lambda cube minus 12 lambda square plus 36 lambda minus 32, and we have found lambda is equal to 2 as one of the solution. So what we need to do is that take 2 and write the coefficients. The coefficient of lambda cube is 1. The coefficient of lambda square is minus 12. The coefficient of lambda is 36. The coefficient of 32, I mean nothing is here, right? Actually it is lambda to the power 0. It is lambda to the power 1. So lambda to the power 0 is minus 32. साइन में ध्यान रखना आप लोग, ठीक है? तो हमें यहाँ पर 0 पुट करना पड़ेगा. We need to put 0 over here. So what we need to do is we need to add up this. 0 plus 1 is 1. 2 into 1 is 2. If we add this we get minus 10, right? Minus 12 plus 2 minus 10. Okay. We need to again multiply this. What we have to do is, remember, just add up this what you are getting, multiply this, add in a column wise and multiply diagonally. Bas, that's the case. Again you have already added this to minus 12 and plus 2 and you get minus 10, right? So minus 10 into 2 is minus 20. It is minus 16, correct? No, sorry, plus 16. 36 minus 20 is plus 16. Again, 16 into 2 is plus 32. Correct. We get 0. So what we get is 1 minus 10 plus 16. Okay. Please note it down in your copy if you are noting it. So let's go to the next page. Remember this. We get the final result as 1 minus 10, 16. 1 minus 10, 16. So what we need to do is, we have already found 1 lambda. So our objective is to find 2 values of lambdas, right? So what is the highest power we should give? Obviously 2. So here the power should be lambda square. Here it is minus 10 lambda to the power 1, that is lambda, and here it is lambda to the power 0, which is 1. This should be 0. Now what we need to do is that we need to solve this equation, and which is very easy. Let's find this from middle term. It's like this. I hope you remembered this. We have done this in class 8 or 9, I think. That here you have to write two factors, 8 into 2. That should be equal to the sum of this one, with the sign given. So let's go to the next page. It is, let's take common. Please note it down, it's important for you. Okay, yeah, here it should be same. You know how to solve this, it's easy. So it's lambda minus 2, lambda minus 8 is equal to 0. It is lambda equals to 2 and 8. So what are the three solutions we are getting? Lambda is equal to 2, lambda is first from the first one as a factor, and that satisfies the equation, equalizes to 0, 2, 2 and 8. Okay, so this video is little bit long. I will make you understand that how to find the eigenvalues from a given matrix in a very shortcut way in the next video. So thanks for watching the video. I hope the concept is clear to you. Okay, thank you.